Chapter 1.9, the problem solving. This is the meat of this chapter. We're going to use all the different things we learned in each of the different sections to solve problems using dimensional analysis. And the advantage of doing this is that later on in other chapters we can still use this process, and it really helps to solve problems this way. It's actually an easier way once you understand the process. So let's get started with it. The biggest thing is we need to identify our problem. We know what's given, and then we need to figure out what we need to get to. Well, that's given in the problem. For example, a person has a height of 2 meters. What is that height in inches? Well, we know where to start. It's 2.0 meters. We need to know where we're going to. We know that because the problem says inches. So we need to look on that conversion chart that in the last unit I put in 2 different places, and you'll see there's a conversion from meters to inches, and we'll use that. But let's do this a little bit more step by step. In this book they happen to call this the Guide to Problem Solving, which is a good thing to call it. I've grown up knowing it as dimensional analysis, so that's also a good way. But whatever you want to call it, the steps: we state the given and we figure out what we need. Number 2, we're going to write this plan to go to see where we're going to get starting today to get to step Z. 3, we need to figure out the equalities, look on the conversion table, and figure out which way we need to set them up so that we cancel the units, and then we calculate our answers. So here we go. You don't need to memorize those steps. You just need to know how to do those steps. It's just a little bit of practice. It starts to make sense, but you got to get to that point first. All right, so for example, how many minutes are in 2.5 hours? Even though you could probably just solve that right off the top of your head, let's start with this easy problem, do it with dimensional analysis so that you will see how to do harder problems. So it's given that it's 2.5 hours, and we need to get to minutes. And so in order to do that, we need to look back on our conversion chart to find our equality, i.e. 60 minutes is in 1 hour. So we could have either set it up that 60 minutes over 1 hour, or that 1 hour is over 60 minutes. So let's see which one we need to choose. We start with what's given. So if you notice down here, the 2.5 hours, we start with that first, 2.5 hours. Now we need to have our hours cancel out. And there's some rule in math that if you have a label on one side of our division sign here, our divided sign here, our numerator and our denominator, that something on the numerator can cancel out something on the denominator. So our H, we need to set up and use the conversion 60 minutes is 1 hour so that the hours cancel out. So now then that the hours cancel out, the only label we have left is minutes, so then all we do is go 2.5 times 60 and we get 150 minutes. Then you go, okay, now then how many significant digits do I need? Well, we start with how many we started with, 2.5. There are 2 significant digits there, so our answer must be in 2 significant digits. There, if you want to be even more specific, go 1.5 times 10 to the second minutes. All right, so a rattlesnake is 2.44 meters long. How many centimeters long is this snake? Well, we know what we start with. We start with 2.44 meters, and we know we have to use our conversions to get to centimeters. And if you don't know that there are 100 cents in a dollar, i.e. 100 centimeters in a meter, then look on your conversion chart and you'll find that. So the only question is do we say 100 centimeters over 1 meter or 1 meter over 100 centimeters? Well, let's see. As we write our plan, we already know we're going from meters to centimeters. Here's our equalities. Well, as we go to step 4 and we see, okay, we start with 2.44 meters. So we know that the conversion of 100 centimeters over 1 meter is the way we're going to do it, not the other way. Why? Because our meters must cancel out. And they cancel out because one's on the top side of our divided line and the other's on the bottom side, i.e. one's on the numerator side and one's on the denominator side. So we can cancel those labels out. So then we have 2.44 times 10 to the second, or 100 centimeters. So our meters cancel out, we get centimeters, 244. Well, let's see, is that the right amount of significant digits? This is applying our significant digits problems earlier in several sections ago. Well, we start with 2.44, which is 3 significant digits. All these other equalities and conversion factors are considered perfect numbers, and we don't need to count them or worry about them in our significant digits. So we can look at 2.44, which is 3 significant digits. So our answer is in 3 significant digits. All right, so how many minutes are in 1.4 days? Okay, why don't you set this on pause and see if you know even where to start. All right, so obviously we're going to start with what's given. 1.4 days is given. We know we're going to get to minutes, but we don't have a way to get from days to minutes directly. All right, well, we're going to have to first go to hours. We know that there are 24 hours in a day. And if you don't know that, we'll look on the chart there that has the conversion chart that has that. And once we're at hours, we know how to convert from hours to minutes. So in this case, this is not just a one-step item. This is going to be 2 steps. So we have our different equalities. We know that 1 day is 24 hours. We can either write it as 24 hours over 1 day or vice versa. 1 hour is 60 minutes. We can either write it as 60 minutes over 1 hour or 1 hour over 60 minutes. However, there's only one right way to do it in this problem. So let's see what that is. All right, we're going to start with 1.4 days. Now that's considered, on top of an understood 1. Just if you want to do that, you can, just so that you know it's a placeholder, so you know that's on the numerator side. That's on the top side. So that means we need to have days cancel out. So our conversion is 24 hours is 1 day, needs to be 24 hours on top over 1 day. Why? So that the day cancels out. All right. Now then, we then have 24 hours. Okay, we need to go from hours to minutes. How do we get there? Well, do we have 60 minutes over 1 hour or 1 hour over 60 minutes? Well, there's only one way that the hours in the 24 will cancel out, and that's if the hours, the 60 minutes over 1 hour, has the hour on the denominator, on the bottom side. So that's why it's chosen the 60 minutes over 1 hour. So when you do that math now that all the labels have canceled out, we're going to go 1.4 times 24 times 60 divided by 1 times 1, and then we're going to get our number. Now then you go, well, how did you get that number? My calculator, didn't look like that. Well, because we have 2 significant digits in our original starting, so that means our number must be in 2 significant digits. All right, so this is just to tell you, back up if you are going along. So let's say that you had started out 1.4 day, and you go, well, I'm just going to arbitrarily, I know that 24 hours is 1 day. Well, if you did that, and you put that the 1 day on top and the 24 on the bottom, and then you went over here and you did your hours to 60 minutes, and you cancel out the hours there. Let's look and see what labels we have left. Let's see, our labels that have not canceled out is a day over a minute. Well, days squared divided by minutes is not any unit that we use. So you know that if you don't get the right units at the end, you didn't do the problem correctly, and then it's time for you to go back and readjust something. Now at this point, I'm going to go to some other slides from another class to help with a few more examples. So let's switch to some other slides here. All right, so as we solve the problem of these different problems, you'll notice this first slide talks about the 4 parts, which is just like what we had talked about before. So here's an example. And it's a nice, easy example, and you could do this in your head, but that's not the point. The point right now is not to get the answer. The point is to make sure you know how to get the answer. All right, 21 yards is how many feet? Well, if you don't know that 3 feet is a yard, then look on that conversion sheet. All right, we start with what's given, 21 yards. All right, so now that we're at 21 yards, we need to use our conversion factor, and our yards, because it's a 21 yards, our yards must be on the bottom of our conversion. So 3 feet over 1 yard. That way our yards cancel out. The label that's left is feet, and we look up here. Yes, that's what they wanted. All right. So now then we're going to go 21 times 3 divided by 1, and that's 63 feet. Now then, that is 2 significant digits, and then we started with 2 significant digits. Great. And you will notice that we do not need to consider the 3 and the 1 in our counting of significant digits because that's considered an exact number. Why? Because that is a conversion, exact conversion. All right. Convert 0.547 pounds to grams. Well, you look up that conversion, but I'll just give it to you right here, that a pound is 4.53.6 grams. So we're going to start with 0.547 pounds. We're going to start right here. Now then we know we got to have our conversion of pounds to grams, have the pound on the bottom side. So we have our pound on the bottom side, the 453.6 grams over 1 pound. Why? So that the pounds cancel out. And the only label left is grams. So 0.547 times 453.6 grams, and we get 248 grams. Again, 3 significant digits in our original problem, 3 significant digits in our answer. All right. So convert 0.348 kilograms to milligrams. Again, we don't really have a direct conversion from kilograms to milligrams, but we have a conversion from kilograms to grams, and then from grams to milligrams. So we know that 1,000 grams is a kilogram, and we know that 1,000 milligrams is a gram. So, since we start with 0.348 kilograms, then our conversion of 1,000 grams to 1 kilogram needs to be in that order, so our kilograms cancel out. Now then, the label that we would have is grams right here. So then going from grams to milligrams, we're going to put the 1,000 milligrams, or 10 to the third, milligrams over 1 gram. Why? So this gram cancels out here and this gram cancels out here. So your final answer, the label is in milligrams. So then you go, okay, so it's 0.348 times 1,000 divided by 1 times 1. And so when we do that, we're going to get that the answer is 3.48 times 10 to the 5th milligrams. All right. So you may have thought, oh, it's just real easy. 1's always going to be on the bottom. No, so far that's just the way the problems have been. So let's look at this last problem here. How many inches are in 2 kilometers? Well, first of all, we know if this is what I'm starting with, 2 kilometers, that my final answer is only going to have 1 significant figure. Okay, just to let you know. But anyway, so here's our different conversions. An inch is 2.54 centimeters. 100 centimeters is a meter. 1,000 meters is a kilometer. All right, so let's see. We're going to go from 2 kilometers to inches. We don't have a way to do it directly. But we can go from kilometers to meters, from meters to centimeters, and then from centimeters to inches. So here we go. We're going to start right here. 2 kilometers. Right? We got to get kilometers to cancel out. So we're going to put 1,000 meters over 1 kilometer. Now right there, this particular kilometer cancels out with that. You will notice that now then I have this meter here. That's my label. So I'm going to use my conversion 100 centimeters over 1 meter. Why? So that this meter here cancels out with the meter on the bottom. All right. Then you have the label centimeters left. So we have this conversion, 1 inch is 2.54 centimeters, and we need to have it that way. We don't want it to have 2.54 centimeters over 1 inch. Why? Then the label wouldn't cancel out. We have to factor out the labels. We have to cancel them. And so by having it where the 1 inch over the 2.54 centimeters is the 2.54 centimeters on the bottom, then that label cancels out. The only label we have left are inches. So it's 2 times 1,000 times 100 times 1 divided by 1 times 2.54. Close your parentheses at that point. And so since, again, we said that we're going to have 1 significant digit at the end, you look at your calculator and calculate that, and you will end up getting 8 times 10 to the 4th inches. If you need additional help, which you might want, the Christiansen video has some really good practicing. I've had a couple of extra links there for more practicing. I highly suggest you look at that. Feel free to ask me if you have any additional questions.